Okay, another example here from 2.9, or 2.4, this is number 9, and they give you this function t, which represents a temperature, big T represents temperature, and little t is time. And they ask you, of course, the big problem in this section is to find a derivative, so they want us to find the derivative of big T with respect to little t. Okay, so that's what we're going to do. We're going to take the derivative with respect to t of that whole function you see right there. Now when you look at the function, it is a big thing, but mainly we have a fraction there, right? It's 10 times this huge fraction, and since we can't really simplify this fraction more than likely, we probably need to use the quotient rule. Okay, so the quotient rule says when you're taking the derivative of a fraction, where you can't rewrite it to get rid of the fraction or anything like that, here's what you do. Okay, you take the derivative of the denominator times the numerator, okay, minus the numerator times the derivative of the denominator over the denominator squared. Okay, and actually, despite looking pretty complicated, this problem isn't too bad. I mean, the actual derivatives you have to compute aren't too bad. So the first thing is I have to take the derivative of this entire expression, including the 10. Okay, 10 times all this. But constants factor out, so I can bring that 10 outside, and then that leaves me with the 4t squared plus 8t plus 75 over t squared plus 2t plus 10. Okay, so that's what I'm actually going to take the derivative of. Okay, so let's look at that quotient rule one more time. Okay, we've got f over g. We take the derivative of the denominator times the numerator minus numerator times the derivative of the denominator all over the denominator squared. Okay, so the denominator has the derivative first. Okay, so here's what we're going to get. We're going to get 10 times, okay, and I'm going to write just this huge line here because I know I've got a lot to write in the numerator. Okay, so the derivative of the denominator, okay, well the derivative of t squared is 2t. Oops, did I write that right? Yes, okay. 2t plus the derivative of 2t, which is 2, plus the derivative of 10, which is 0. Okay, so that's my derivative of the denominator, and I multiply that by 4t squared plus 8t plus 75. Okay, minus, and I think I'm going to even need a little bit more room here. Okay, minus what? The derivative of the numerator. Okay, times the denominator. Okay, so something like this. Okay, now the derivative of the numerator is going to be 8t plus 8, okay, plus 0. Derivative of 75 is 0, and that's all times the denominator. Okay, and this is all over the original denominator squared. Okay, that's what goes in the bottom of the quotient rule, the original denominator squared. Okay, now this one's a little tricky because you've got a lot of stuff here. You could multiply everything out, but one thing I can do just to save a little bit of time, it's not a huge deal. I mean, the real way to finish this is multiply everything out in the numerator and collect, combine like terms. But one thing I noticed here is that that's 8t plus 8. So this term I can write as 4 times 2t plus 2. Okay, why do I just factor out the 4? Well, because then I see that these two big terms have that same factor, 2t plus 2. Because right now we've got the derivative, we just need to simplify it. And here's what I'm going to have: 10 times 2t plus 2. Okay, and look here carefully what I'm doing. I'm factoring out that 2t plus 2 from both of these big expressions in the numerator. And all I have left now is the 4t squared plus 8t plus 75, okay, minus 4 times t squared plus 2t plus 10. Okay, and that's all over t squared plus 2t plus 10 quantity squared. Okay, so again, I had 10 out here, but then I had two big terms in the numerator. Both of them had a factor of 2t plus 2, so I factor that out, and this is what I have left. Okay, and actually, what you'll notice is, I think we get 4t squared plus 8t plus 75, okay, minus 4t squared minus 8t minus 40. Okay, and that's all over that denominator squared. T squared plus 2t plus 10, okay, the whole quantity squared. Okay, so look at what happens here. A lot of these things cancel. And by the way, if you had just multiplied everything out in the numerator, you would have seen that, but I just wanted to save myself a little work. So I think at the very end, what I should end up with here, it looks like I just have 75 minus 40, and that's 35. So I've got like 10 times 35, that's 350, times 2t plus 2, okay, all over t squared plus 2t plus 10, the whole quantity squared. Okay, and again here, if I wanted to, there's no reason to leave this factored. Of course you can if you want, but it's going to be something like 700t plus 700 over t squared plus 2t plus 10, quantity squared. Okay, and that's the derivative, and if you get this right, then to answer their question, I think they wanted you to compute some values of the derivative. You just got to put that number, or those numbers in for t and compute the value. And when you're doing that, I think most people are probably okay with that part. But be careful in these problems. If they ask you to find the value of the derivative, they probably want an exact answer unless they tell you how to round it. So I think on this problem they said round your answers to 2 decimal places. Okay. Well, if they say that, then round it to 2 decimal places. But otherwise, type a fraction. And again, if you get something like 1/3, you can type it in the boxes on WebAssign as 1/3, and that's what they want to see. If they tell you to round it to 2 decimal places, then you would type something like 0.33 in. Okay.